This video looks at network flow problems where we have minimum capacities on the arcs. So you can see here we have two numbers instead of the usual one. The second number is the normal number, the one that shows us the capacity that can flow through the arc. But the first number indicates a minimum, so there is a minimum flow. So with previous networks we've been able to assume that we can have zero flowing through an arc. Here we have minimums that aren't always zero. For this reason we have to think about cuts a bit differently, because whereas before when we've considered a cut we've looked at expecting the maximum to be flowing from source to sink, so where an arc's going from source to sink we've expected the maximum to flow through it and the minimum of zero to flow through any arcs that are directed from the sink to the source. Now we have to consider the minimums. If we look at this cut here, we can see that we have SA flowing from source to sink, but AB goes from sink to source. BC goes from source to sink, but CD again goes from sink to source, and then finally DT goes from source to sink. So we could have 10 flowing through DT, 5 through BC, and 8 through SA, giving us that maximum flowing from source to sink there of 8 plus 5 plus 10. But we also have to consider that although we can have naught going through AB from sink to source, from CD we have to have 4. So we have to subtract that 4 because we can't assume 0. So this is how it works then. You can see there the arcs flowing from source to sink and the arcs flowing from sink to source. So we've got our 8 plus 5 plus 10 going from source to sink and subtracting the minimum capacities on the two arcs that are flowing from sink to source. So the value of that cut is 19. This is the minimum cut for this network. We can see here we've got AC going from source to sink with a capacity of 4. We've got BC going from source to sink with a capacity of 5, and DT going from source to sink with a capacity of 10. We also, however, have CD going from sink to source with a minimum of 4. So we need to subtract that 4, and we get the 4 plus 5 plus 10 minus 4. So the value of our minimum cut is 15, so we should be able to find a maximum flow of 15 in this network. Unfortunately, with networks with minimum capacities, this isn't as easy as with previous networks, because before we start, we have to modify our labelling procedure. We do this by looking at the minimum capacities that have to flow through each arc. These are the red numbers on the arcs. Those are the minimum capacities. You can see they correspond with the first number. If we look carefully at the network, we can see that there may be some problems there. If we look, for example, here at vertex C, we have a minimum flow of 4 out of it, but only a flow of 3 into it. So we need to increase the minimum of one of the two arcs going into it to make it 4. We need to do this for the whole network, so we're going to work through systematically now to achieve just that. We'll start with D. With D we have a flow of 1 plus 4 going into it, so we need to increase the flow going out of it to 5. So we can see here we have the 4 and the 1 going in and only 4 coming out, so we need to increase dT's minimum there to 5. And we will now work through the whole network doing the same thing. At C, as we'd already discussed, 4 coming out, 3 going in. So if we increase AC to 2, that will achieve 4 going into C. We do the same for B. And we now have a situation where everything works. What we now do is we show our excess capacities and potential backflows. The excess capacities being the forward arrows and the potential backflows the backward ones. And those figures will be related to the minimum numbers we now have. So for example, for AC, we could potentially increase that flow of 2 by 2, and we could potentially decrease by 1. So we put forward arrow of 2, backward arrow of 1. We again will do this for the whole network. So if we start with SA, where we can increase by 6 and cannot decrease, we put 6, 0. For SB, you can see here that we can increase by 6 from 3 to 9 and decrease by 2. So we put 6 and 2. And we continue this now for the rest of the network. We now run the labelling procedure exactly the same way as we've done before. So we look for augmenting paths. We'll start at the top as normal, so 6, 2, 7 are the capacities, the excess capacities on the 3 arcs. So it's AC with the capacity of 2 that's the smallest, so we can only send 2 through that augmenting path at the top. We then decrease the excess capacities by 2 and increase the potential backflows by 2. Do the same for other augmenting paths, noting here that AC is now saturated, so indicate that. SABCT, we have a minimum of 3 there, so we do the same there, increasing the potential backflows and decreasing the excess capacities. We now have 2 more saturated arcs, so indicate that. We now go along the bottom, SBDT, we can send 5 through there. We have 6, 7 and 5, so we go with the 5 on DT. Make sure we do the labelling as we go along, and we've now saturated DT. You'll now see that we've disconnected the source and the sink, and if we look at the backflows, it would indicate from the previous labelling procedure a flow of 5 through CT and 6 through DT, meaning a flow of 11. But don't forget that we considered our minimum capacities. So what we need to do now is put the minimum capacities on each arc and add this to the backflows. And that will give us the actual flow through each arc. So we can now see that we've actually got 10 flowing through DT, 6 plus 4. We have 5 flowing through CT, that adds up to 15, so we've achieved our maximum flow from that minimum cut. We look at the other end just to check. At the source end we have 7 plus 1, 8, and 5 plus 2, 7. So So there we can see our actual flows through each arc, and we can see that we've achieved our maximum flow as expected. And if we put that back now on the original network with the flows, we can see that we've achieved our aim, and this is what it looks like. Okay, I realise that's complicated. I suspect that you may need to go through this video several times, or at least parts of it, but try your best to understand it. We'll be reinforcing this in the lesson, but I will expect that you will understand the basis of this, the basics, the foundations of it, so we can start not right from the beginning, but we can start getting some practice in to consolidate this in the lesson.